Somewhere in a coral reef, something moves faster than your eye can register. Not a shark, not a barracuda, a shrimp, 4 inches long, just threw a punch that accelerated faster than a bullet fired from a .22 caliber handgun. It happened in under 0.003 of a second, and it just boiled the water around it. This is the mantis shrimp, and what it does next will change how you think about the word small. Meet the peacock mantis shrimp, a creature so strange that for decades aquarium owners nicknamed it the thumb splitter, because it's shattered aquarium glass on more than one occasion. Its front legs end in a pair of club-like appendages, folded back like a loaded spring. And that's exactly what they are, a spring, not a muscle. Most animals throw a punch the way you'd expect. Muscle contracts, limb moves. But muscle alone can't move fast enough for what the mantis shrimp needs. So evolution built something closer to a crossbow than an arm. The mantis shrimp slowly loads tension into a saddle-shaped structure in its exoskeleton, storing energy the way you'd pull back a bowstring. Then, a tiny latch releases. All that stored energy fires at once. The claw accelerates at over 10,000 times the force of gravity. It hits its target in under a millisecond. If you scaled that motion up to human size, this shrimp would be able to hit a baseball out of a stadium, twice, before the ball reached the pitcher. But here's the part almost nobody knows. The claw itself never touches most of what it destroys. When the mantis shrimp's claw moves that fast through water, it doesn't just push water aside. It moves so violently that it drops the pressure around it low enough to literally rip the water apart, creating a pocket of vapor called a cavitation bubble. That bubble is unstable. Microseconds later, it collapses in on itself. And when it does, something extraordinary happens. The collapse is so fast and so violent that the temperature inside that bubble briefly spikes to nearly the temperature of the surface of the sun. For a fraction of a millisecond, inside a bubble smaller than a grain of rice in the middle of the ocean, that collapsing bubble releases a second shock wave, meaning the mantis shrimp doesn't hit its prey once, it hits it twice. Once with the claw, once with the bubble. Prey that somehow dodges the claw itself can still be killed by the shock wave that follows a fraction of a second later. There is no dodging this attack. There is only being close enough, or not. And the strike isn't even the strangest part of this animal. The strangest part is how it sees the world. Human eyes have 3 types of photoreceptors, 3 channels of color information combined by your brain into everything you've ever seen. The mantis shrimp has somewhere between 12 and 16. It can perceive ultraviolet light, polarized light, and wavelengths that don't have names in human language because we've never needed one. Each eye moves independently on its own turret, scanning the reef in a way no other creature does. And strangely, despite having vastly more color receptors than us, some research suggests the mantis shrimp's brain may process color more simply than ours, using a kind of fast pattern check instead of the rich blending our brains perform with only 3 channels. Nature didn't just give this animal more equipment, it gave it a completely different strategy for solving the same problem, understanding what's out there before deciding whether to strike or hide. 2 completely different engineering solutions, a spring-loaded weapon system and a multi-channel optical sensor, sitting inside an animal you could hold in one hand. And it turns out, humans have been paying very close attention. Materials scientists studying the mantis shrimp's claw found something odd. After thousands of strikes at those forces, the claw doesn't shatter. Inside that claw is a spiral, layered structure. Fibers wound in a helix, each layer rotated slightly from the one below it, like sheets of plywood twisted into a corkscrew. When a crack tries to travel through the material, that twisting structure forces it to change direction constantly, bleeding off energy instead of letting the crack run straight through. Engineers have used that exact layout, a herringbone, twisted-ply structure, as inspiration for impact-resistant body armor and aircraft panels designed to survive repeated impacts without failing. A 4-inch reef animal solved a materials engineering problem that human labs are still trying to fully replicate. It didn't publish a paper. It didn't file a patent. It just needed to survive long enough to eat and to avoid being eaten. That's the pattern you'll see again and again on this channel. Nature isn't decorating the world. It's solving problems, under pressure, over millions of years, with no room for a design that almost works. The mantis shrimp didn't need to impress anyone. It needed to survive. And in solving that one problem, it accidentally built one of the fastest weapons and strangest eyes on the planet. If you want to see the next design nature perfected long before we did, stay close.